Today's video is on integration using residues. In today's video, we are going to find the poles and residues at each pole of the function f of z is equal to 1 by z square plus 4 whole square. See, first of all, we have to find the poles for the given function. So, what is the function value given? So, f of z is given as 1 by this is z square plus 4 whole square. So z square plus 4 can be written as f of z can be written as 1 by this is z plus 2y into again this is z minus 2y whole square. See here a plus b into a minus b is nothing but a square minus b square. Here I square value is minus 1. So this can be written as z plus 2y into z minus 2y whole square. Therefore, our function value f of z value is nothing but 1 by this is z plus 2y whole square into z minus 2y whole square. Now, in order to find the poles for the given function, we have to equate the denominator value to 0. So this denominator value, that is z plus 2y whole square into this is z minus 2y whole square, we have to equate this to 0. So this will be z plus 2y whole square is equal to 0 and z is equal to minus 2y. See here, z is equal to minus 2y is a pole of order 2, is a pole of, this is order 2. So if I equate z minus 2y whole square to 0, then z is equal to plus 2y. So which is a pole of order again 2. A pole of order 2. See, we got two poles. One is z is equal to minus 2y and the next one here is z is equal to plus 2y. So clear? So here we have to find the poles and the residues at each pole of f of z is equal to 1 by z square plus 4 whole square. First of all, the function here is 1 by z square plus 4 whole square. This can be written as z plus 2y into z minus 2y square, and this is nothing but z plus 2y square into z minus 2y square. So for finding the poles, we have to equate the denominator to 0, and after equating denominator to 0, we got the pole values as plus 2y and minus 2y, which is of order 2. And now we have to find the residues. See here, residues at each pole. So first pole is I am taking as residue of, see, residue of the function at point z is equal to z naught will be, the formula is 1 by m minus 1 factorial into limit z tends to z naught. This is d by dz power, this is m minus 1 into this is z minus z naught power m into f of z. Clear? And therefore in this we have to keep our order value. See here, what is our order value? 2. So m value is equal to 2 and the residue value here I am keeping as minus 2y. So now this value will become, this is residue of f of z at point z is equal to minus 2y is nothing but 1 by m is equal to 2, that is 2 minus 1 factorial into limit z tends to z naught is nothing but the pole value, that is minus 2y. This is d by dz times of 2 minus 1. So this is 2 minus 1. This is z minus z naught value is plus 2y part m. So m value is 2 into f of z. So what is our f of z value? So f of z is nothing but this one as 1 by this is z plus 2y square into this is z minus 2y square. Clear? So I'm cancelling the z plus 2y square from numerator as well as denominator. So this will be 2 minus 1 factorial is again 1. So this is limit z tends to minus 2y. This is d by dz times of derivative of, this is 1 by z minus 2y square. So we have to make a derivative for this, and again we have to substitute z value as minus 2. So the derivative of 1 by x square, see, for example, the derivative of 1 by x square is nothing but minus 2 by x cube. So if I take 2 to the numerator, this will be x power minus 2 and x power n is nothing but n into x power n minus 1. If I substitute here, this will be minus 2 by x cube. So after making a derivative, see, this will be limit z tends to minus 2. This will value is minus 2 by, see here, this is z minus 2y whole cube. In this I have to keep minus Z value is minus 2i. So this is minus 2i whole cube. So this is minus 2i. This is minus 4i whole cube. And this is minus 2 by. See here, this value is minus 4 cube is minus 64. And I cube, for I square, this is plus 1. And I remains. So if I cancel this into table, so this will be, for I square I am writing, for minus 1 I am writing I square, and this is 32i. If I cancel I for one time, the value here is I by 32. This is the residue value of f of z at point z is equal to minus 2i. For point z is equal to minus 2i, see here, the residue value here is I by 32 is the residue value. For the pole value, z is equal to minus 2i. And see, for the next pole value, so what is the next pole value? Z is equal to plus 2i. Again, for z is equal to plus 2i, the same formula. So if I substitute here in this formula, as the pole value here is m value, order value is equal to 2, and pole value is equal to plus 2i. So if I substitute in the same formula, this will be, see here, this is residue of f of z, residue of f of z at z is equal to plus 2i. So this is m minus 1. So this is 2 minus 1 factorial into limit z tends to 2i. This is d by dz times of m minus 1. This is 2 minus 1 into z minus 2i bar m. M value is 2 and f of z value is nothing but, see here I am showing f of z value is this one, that is 1 by, this value is z plus 2i square into z minus 2i square. So if I cancel these two, then see, this will be 1 by 2 minus 1 factorial is 1 factorial. Limit z tends to 2i. This is d by dz times of 1 by z plus 2i square, and again the derivative, see here I am writing the derivative of, 1 by x square is nothing but minus 2 by, this is minus 2 by x cube. Now this value will become, so this value will become 1 by 1 factorial is 1. This is limit z tends to 2i. The derivative for this is minus 2 by, this is z cube, that is z plus 2i whole cube. In this, if I keep z value as 2i, this is minus 2 by, this is 2i plus 2i whole cube. So the value here will be minus 2 by, this is 4i whole cube. So this value is minus 2 by, this is 64, and I cube for I square. So I square value is minus 1. So this is minus and I remains. So if I cancel this, this will be 32. I got cancelled, and therefore the value here is 32i. This is the residue value of f of z at z is equal to 2i. At z is equal to 2i, we got the residue value as 1 by 32i for the corresponding pole z is equal to 2i. So this is how we have to solve. See, let me explain you for one time. So this is the function f of z is equal to 1 by z square plus 4 whole square. So we can write this as z plus 2i into z minus 2i whole square. So after splitting this one, so we have to equate the denominator to 0 in order to get the pole values. So we got z is equal to minus 2i, which is a pole of order 2, z is equal to plus 2i, which is of also order 2. So here, this is the formula. In this, m value, the order value is equal to 2 and the pole value is minus 2a, and after substituting and making derivative for one time and again substituting z value as minus 2i, so I by 32 is the residue value. And the next one here is m value is equal to 2 order value, and the pole value here is plus 2i, and after substituting in the function and after cancelling and making derivative and substituting z value as plus 2i, we got the residue value as 1 by 32i. So this is how we have to solve. Thank you so much for watching. If you really like this video, please pass it on to your friend and practice well, so your consistent practice will make you to score more. Thank you so much for watching.